Hey folks, how's everybody doing today? Happy Thursday. Hope you're keeping warm and out of the snow and got shoveled out finally. It was not quite the snowmageddon that was promised, and my kids are very disappointed we didn't get 18 inches. I think maybe we got 4 or 5. I'm a little disappointed myself, but that's okay. Didn't have to drive anywhere in it, so I was a little spoiled. So I saw a couple more submissions come in just before the buzzer here. Thanks for getting those in. We'll talk about Project Zero today, and then we'll do a little bit more around these array-based sequences, and then we'll talk about the next project. That sound like a good plan? 15 in with 18 people. Okay, that should work out okay, I think. It's reasonable. Let's go take a look. And make our pie charm here. Hey, KMP. Maybe. Pie charm, there we go. And we'll look at the project. Is it going to lag again? It's not my computer. We'll let them slow down. Gotta order that new laptop. I just don't want to spend a bunch of money on it. Let's see. Yeah, I think it might just be pie charm. We'll see. Yeah, we got a little bit of room, so hopefully a little more stable now. Anytime it gets 100, it gets a little slow there, right? Go figure. It's desktop window manager. I gotta figure out what to do to kill that. Should not be using all my GPU. All right. Oh, almost got pie charm. And like we talked about, there's a couple of different ways you could have gone with this. So it's not, necessarily this was the hard and fast. This is the only way you can do it. You're allowed to go and change some of these things if you wanted. So we'll take one approach and we'll see how well it goes. Okay. We'll go from there. All right, it's almost loaded. Should have started this sooner. Sorry. I guess it's time for coffee. All right. Maybe. I think my computer knows it's a snow day too. There we go, new project. All right, call this one Project Zero. And again, I like putting things in separate files for classes. If you don't do that, that's okay. It's no problem at all. I just think it makes things a little bit cleaner to organize all your files and classes, but that's just my preference. So no big, you don't do it that way. So I'm going to add a new file here for ship. Maybe we just do them all in one class, I guess, and maybe we'll call that good instead of one each. So this will be ship. Hey, thanks for coming along. Is that Chloe? Cool cat. All right, so here in the ship module, then we're going to start defining our classes. We're going to have a class for ship. Init method. Now, init, we can take a bunch of parameters, right? This idea with the init is going to take a bunch of these values here, right? So we wanted, I'm going to just copy paste that. It'll probably be really ugly to copy paste. We'll try it. So we want name, we want X, we want Y, we want the alignment, we want the max health, we want the range. Now, range is giving us a warning that we're like We already have this thing called range, so maybe that's not the best term for it, but we'll probably make do. Should we call it attack range? We don't get that warning, maybe? What attack range? Cool. And then we can set all these values. So self.name is the name, self.x position is the x, self.y position is the y. I don't think it was required to get any of these private, right? I didn't name any of them with the private sort of naming convention, so it should be okay. We wanted self.alignment is the alignment. We wanted self.max health. Oops. Hope if I can spell that right then. Alignment. Nope. Alignment. There we go. Max health is the max health. And then we also wanted a current health, right? Current health. We're going to start off as the max health. And then an attack range is the attack range. And a self.attack power is the attack power. Okay, so that should do it for now. And as we need to go add more things, we can add more things later. And we also want that alignment class as well. So we want a class for alignment, inherits from enum. All right, we talked about enums on Tuesday a little bit. So we want from enum import enum. I think capital E, right? Yeah, capital E enum here. And then we just can have our values, right? So we would have us equals 1, we'd have them equals 2, and how about chaotic? Chaotic equals 3. Okay, so we can use these alignments here then. Why is it upset about alignment? Am I spelling it wrong? I did, I spelled it wrong. Again, alignment. There we go. We can use those alignments then throughout our classes here. Okay, and then we're going to have get type, get x, get y, get alignment, status, move, change alignment, assess damage. So we got a couple more things to work on here. So let's do the gets first. So how about we define a get x, return self.x position, and a get y. Y will return the self.y position. Okay, those ones were pretty basic there. A get alignment. Get alignment. Return self.alignment. Probably need something for the health, right? Self.get current health. Return self.current health. I'm not sure if that one was in here, but that's going to be useful later, like if we want to get their health to and assess damage, keeping within bounds of 0 and max. We can do that. So those are the gets. We'll leave those down below because they're boring. So we can do an assess damage. Assess damage, given some damage. Now we need to keep it between 0 and max, right? So we can say my self.current health minus the damage, and then I can do those checks. I can say, hey, if self.current health is less than 0, we'll set it to 0. And if self.current health is greater than the max health, we'll set it to max health. Current health is the self.max health, right? Put ourselves back to max. So, and this could be an elif, I guess. It'll save one little check, maybe. Not too big of a deal here. So when we're looking at this function here, we know when we go to do our tests here, we're going to have to test a case where we get below 0 and a test where we get above max to make sure that both of these lines of code will run, so we get that 100% unit test coverage that we're talking about. A change alignment changes us to them to us, and chaotic never changes. Okay, so we'll add a change alignment method. Change alignment. So if self.alignment is equal to alignment.us, then self.alignment will become alignment.them. Elif self.alignment equals alignment.them. We'll change it to us. Self.alignment. I think I can copy that. My fingers don't want to type today for some reason. I don't know. Maybe I have to do some more finger stretches. That's it. But nothing happens if they're chaotic. So just two cases. Us to them to us for change alignment. Okay, a get type here is going to return the type. So they're going to have to probably override that, possibly. So how do we have a define get type? Now for ship, I guess we can just return ship, maybe? Didn't really specify what it should do for the ship class, right? It's whatever it is. That's fine, but the other ones can override that. And then about a name. Name wasn't super clear. If this was its own individual name, like the USS Enterprise, cool. And then type would be a different thing. I think makes sense there. Oops. Well, yeah, so for all ships, it's always ship. That makes sense. So we might want to have then a get name. Get name, return, self.name. Sure, we can do that one. All right, we still need attack, and we need status, and we need move. So change the position and increase its health by 1. So we can do move, at least here. We can do define move. Now, we could just increase our current health by 1, but then we need to check to see if we don't go over the max. And I feel like it'd be easier for us to just assess damage. Where'd it go? Assess damage. -1, because we know that is already going to make sure we don't go over the max. Right, so I think this is probably the easier way, right? Easier for us to do this way than to repeat the logic. Does that make sense? So we can we'll just assess damage -1. We'll use our own method that already has, making sure we don't go over max. We move, and then there's nothing else to move really. So we're fine here. Let me take care of some of these spaces. Those are going to bother me. Okay. All right, how about attack then? We're going to define the attack method, and we need a target. So target should be another ship. And this idea with attack, we're going to attack another type of ship. Does the attack power damage to the ship if it's within range, and if it's a different type, right? Remember when we look at attack here, attack works if there's the opposite alignment and within range. So us attacks them attack us, chaotic attacks everybody. So a couple things you need to check then is if they're within range and if we should shoot them, right? Does that make sense? So we want to say if self dot, I don't know what should shoot at, given the target, right? And self dot is within range of the target. Then we can actually go do our damage to it, right? Then we can say target dot assess damage, self dot attack power, right? So if we should shoot at them, they're on an opposite team, and they're within range, let's assess our damage. That's our regular attack here. So now we need those helper methods, right? We need, okay, should we shoot at, and are they within range? So we can define those. So this is should shoot at, given a target. So here we want to say if our self.alignment is equal to the alignment.chaotic, right? That's for sure yes, right? We're going to do that. So we're going to return, right? Because we don't need to say if true, return true. We can just return a value. So if we're chaotic or self.alignment does not equal target.getAlignment. Right? If we're chaotic or we don't match theirs. So if we're us and they're them, don't match, that's true. If we're them and they're us, don't match, that's true. If we're us and they're chaotic, we shoot. If we're them and they're chaotic, we shoot. If we're them and them, that's false. And this is false, so the whole thing would be false. So I think that works for our checking here. And then we need the is within range. Define is within range, given a target. Now in this case, we need to check our range. So we're going to return our self.attack range is greater than or equal to. Now we need to find the distance between 2 points, right? So it's math dot square root, right? So a squared plus b squared equals c squared. So the distance between those two, right? We can do our little Pythagorean theorem here. So we'll take self dot x, and we'll add target dot get x here. So we'll take that one squared plus, let's bump this down a line here. Here, maybe we'll bump all that square root down a line. Plus, and then we'll do the y's squared. Self dot get y and target y squared. And we'll take the square root of that. Right? Here's the a squareds, here's the b squareds, we get c squared, so we need the square root of that. If our attack range is greater than or equal to that, they're within range. Right, I think that fits. That seems right. That makes sense? I think that one checks out. It's been a little while since I've done some math, but I think that's how that's going to work. Sorry, because we're like -2 and they're at 2. -2 plus 2 is 0. That's not right. Do I have to subtract? Yeah, it should be minus, right? Minus. So if I'm at -2 and they're at 2, we'll be at -4 is the distance. If I'm at 2 and they're at -2, it's still +4. Okay, yeah. Thank you. That's what I'm looking for. This basic math is hard, right? All right, so now we know if we're within range here. Right, yeah, difference between the positions, locations squared. Okay, so I think we got that here then. And then we just need status. So we're going to get their name, their type, their health, and their location. So we're going to turn a string. So we want to define status. We're going to return a nicely formatted string. So we're going to return something.format, right? So we're going to have the name, right? Or just regular name here. Okay, so just name. And then if you want, we can do these new lines ourselves here. This one's a little bit ugly here, but I think it'll probably work out if that's okay. And then we'll have name, and then type was going to be another substitution here, right? And then we're going to have a new line, and then we're going to have a health, and another substitution, and a new line, and we wanted location, and x, comma y. Right, and then we'll format that with the name, right, self.name, and then the self.getType, and let me bump this one down a little bit here. GetType and self.getCurrentHealth and self.getX and self.getY. Now I could just use our own variables here. I don't need to use all the gets. I could just do well, getType I need because we don't have a type attribute. We just have a getType method. Right? There is no attribute of type I can use here. I just have name, but current health I could get at, and X and Y I could get at, but either of those should work. Okay, so now we should be able to make ships. Just a standard ship here. Just make a standard ship. Okay, there we go. So that was ship then, and then we're going to do our battleship. Derives from ship. It has a specific range, a max health, and attack power, and it has a number of torpedoes. So we're going to define a class for battleship. Derives from ship. Right, so we need to define our own init method then. Now, battleship probably needs a name here, right? Because we need to give a name to our parent class. Probably want an X and a Y, right? This is, if we take an X and a Y, probably needs an alignment, right? These sorts of values here. So we're going to ask for those same ones in our constructor here because we don't know what they are. But then we're going to say super dot init, and we're going to give it the name, the x, the y, the alignment. But now some of these other variables here, I know what the max health is, right? Max health is going to be 100. So our range here, max health is 100. And then our attack range was 10. And the attack power was 10. Right? For that one. So we can just give those values without having to ask for them here. And then I can have a torpedoes, 10 torpedoes. Did I spell it wrong? Torpedoes. Did I spell it wrong in this one too? Oh, O-E-S. Is that better? Okay, that one better. We'll have a number of torpedoes. Now, what's different about Battleship, right? It has a move method. So when it moves, we're going to call super.move. Then we want to take our x and y, and we want to change those x and y values, right? We're going to move along -1, -1. Now, they're marked as private, so it's kind of considered bad form to say self.x location -1. It's going to warn me here that, hey, I'm accessing a private attribute. I think we get that warning. Self.y location -1. So this is a little bit ugly here, trying to get at those private attributes here. Is it x location, y location? I think it is. Oh, x position. There it is. Position. And y position. Right? Kind of bad form. So it might be better then if we had additional pieces of information passed to our init here. Right, we could if we wanted to. So we could have a x move vector and a y move vector. I like that. So this is the x move and a y move. And we could just default them to 0 if we don't know. Right, and then we'll have self.x move, and a self.y move, y move. So then when we call move then, we can take self.x location, x position, minus equals the x, actually what, plus equals, right? The x move, and self.y position, add the self.y move here. So then I don't need to do anything with this up here at all. I just need to pass them as arguments, -1 and -1. So that's a little easier, I think, for move, and then probably a little cleaner, so we're not accessing those attributes that probably should be private. I think that works out pretty well. And then we need to change attack. Right? So we want to do that same thing that the superclass does, but we want to change our damage. Now, we've got two options for this. One option is we have to repeat some logic, and second option is we cheat a little bit. Not really sure one way or the other which is the better approach here, but we'll see if we can kind of mess this one a little bit. So let's say, hey, if self.torpedoes is greater than 0, I'm going to say my attack power equals 20. Okay, we're just going to change our attack power. And then if it's not greater than 0, self.attack power is 10. Then we'll say super attack. Attack the target. So we're just going to kind of cheat here, and if we fire a torpedo, so I guess this is the other tricky part. If we're firing a torpedo, we need to decrease that by 1. So maybe this doesn't work quite as well as I wanted it, because we still need to see if we're within range. Or you might say, hey, every time you try an attack, you lose a torpedo. That's probably not ideal, because we're not going to shoot at friendly targets here. So maybe we do need to do a little bit of repeating, and that's probably okay. So that's fine, we can do that. So we'll say if self.should attack, should shoot at. Yeah, we'll just copy this line here. So if we should shoot at them and they're within range, right, then we'll take target dot assess damage. We can say assess for our regular, we'll just do the regular attack power. And then if self.torpedoes is greater than 0, target.assess damage, we'll do an extra 10. And then we'll take our self-torpedoes down by 1. Right, so we'll hit them for the regular attack, and then if we are shooting at them, we'll use that torpedo. Again, a couple ways we could have gone about that. That's probably okay, one way or the other here. Okay, so that's Battleship. Right, so the only thing different about Battleship. Attack if there's a torpedo, does an extra one. The status then it needs to include the number of torpedoes. So we should include that in our status string. So we're going to define status. We're going to return super.status plus, right, a new line and torpedoes plus self.torpedoes. Right, probably as a string. We'll just make sure we force that as a string, right? So it's string this way. Yeah. As a string, just to make sure it gets put in there, right? I know I'm feeling bad. I guess we should just format it, right? Dot format. We'll format it in the torpedoes there. Right, and actually this could all be its own little substitution here too. Right, so here's a string, then here's torpedoes. So then the first one is super status. And then the next one is my self-torpedoes. There, look at that. That's an even nicer format, isn't it? Okay, so that's Battleship. Then Cruiser, the only thing that's different is it's vector. It's range, max health, and attack power. So that makes this really easy then. So I can have a class for Cruiser, derives from ship. We want to define init. Now, init needs a bunch of these things though, right? We still need, I'll probably copy it from Battleship here, right? Let me copy Battleships. X, Y, name, and alignment. And then we're going to do this super thing. Here we go. Now, our max health is 50. The range is 50. The attack power is 5. And our vector for moving is 1, 2. Now this is a little long here, so we might want to take advantage of some of these named attributes. Right? I can say max health is equal to 50, and then I can say my range is, oh no, I'm sorry, yeah, range is equal to, range was 50 as well. Range is 50, and then our attack power, oh, that was attack range, bummer. 50, attack range is 50, attack power was 5. This gets a little long here, so we can bump these down if we need to. And then our X move was 1, and our Y move was 2. Right? If we use these named arguments here, it makes life a little easier for us, because a lot of these ones are a little funky here, right? So I think this is probably cleaner to use the named ones here than what we did for ship or Battleship, because it's really easy to get those mixed up. So if you can hard code them, right, we can name them. This will just take advantage of that. Cool, and that's it for Cruiser, right? That's the only thing it does. Nothing else special. It still attacks, it still moves. Sure. And then Corvette derives from ship. Now Corvette has a special attack, right? It has a range and a max health. So we'll define class for Corvette. Derives from ship. So it has a similar thing here. So we'll init XY, so its range is 25. Range is 25. Its max health was 20. Oh no, that was repair ship. Range max health is 20. Yeah, for Corvette. 20. Oh, it didn't need fire, so we can close that. Maybe we can close it. not even let me close it. There it is. Close. All right. And then the vector for moving here was 5, 5. Okay, sure. So moves by 5, move by 5. Now the attack power doesn't really have an attack power, but we still need to pass it. So we're going to give it a 0. We've got to be specific here. Then we can change the attack given a target function here. Now, this one, it's only going to convert opposite alignments. It won't convert chaotic, but it can, right? Because chaotic's not going to change anything, right? So if we should shoot at, right, if they're not our team and they're within range, we're going to say target.change alignment. Right? Use the change alignment function that we wrote to change their alignment. If they're chaotic, nothing changes. Right? With change alignment, doesn't matter. So if they're not our team, right, and they're within range, we'll shoot at them. They're Corvette. Now, repair ship derives from cruiser, so it has a range and a max health that's different than cruiser, but it has the same movement vector. That's all. So it keeps the same movement vector. So if repair is a type of cruiser, we'll say, hey, class repair ship, or repair is a type of cruiser. So our init then still needs XY alignment. Now the problem is the cruiser init here only takes name, XY, and alignment. I can't pass it a max health, an attack range, or an attack power. Right? It's not available to me because my superclass directly is cruiser. So then I can go change some of these things, which is a little bit ugly, but we can do that. We can change our attack range to 25. Right? Range is 25 for repair ship, and max health is 20. Now the problem with changing max health, right, is that it previously was set to 50, and the init here for ship is going to set current health up to that. So we also need to go change our current health then. Self.current health to 20. So that's kind of annoying. Here we have to use the right go in and change these things because my direct superclass doesn't have those. And we could add them if we wanted with defaults, but again, got a couple options. And the repair ship has a totally different attack as well. So it's only going to attack people that are its team. So us will repair us, them will repair them. So we could say if self.is within range, right, of the target, and self.alignment is equal to target.get alignment, right? If we're the same alignment here, and I said there's not going to be chaotic repair ships because it wouldn't make sense here, so we can just say, hey, if we match, we're not going to have a repair ship targeting another one here. So we can say target.assess damage, and we can just say like the negative, how about negative target.max health, right? Take their max health, make it negative. Yeah, it's protected access. It's maybe a little bit bad form, but we don't have a get. I guess we could write a get max health if we wanted. Why not? Why not? Define get max health. Turn self.max health. Here. Get max health. Now we're doing better form. We're calling a method here. So we'll get their negative max health, assess the damage, which will heal them back up to full. Okay, let's our repair ship. That make sense? Now we need some unit tests. Right, so what we're unit testing then is anywhere we have code, anywhere we have branches. So what we specifically need to unit test then in Battleship is if we have a torpedo, it does extra damage. We technically don't have any code that changes if we don't have torpedoes. So just by testing if we have a torpedo, we're technically have 100% code coverage. We might not feel good that this actually works though. So maybe we want to shoot 10 times and then see if we still have a torpedo after that. Right? The other funny thing we don't have in here with our should shoot at, we're going to attack ships that are blown up. So if there's a ship still at a given location, we're still going to shoot at it, even if it has no health. Right? And we're not going to do any extra damage to it, but that's just kind of how we wrote it. So maybe that's okay. You know, not too big of a deal. We'll see. Okay. For cruiser, really, there's not much to unit test. We can create one and then make sure we get all the right values back out, I guess. That's about it. For corvette, we want to make sure that attack works correctly. And for repair ship, we want to make sure that attack works correctly. Okay. So let's right-click and go to test. So go to test. It says that none exist, so we'll create some new tests. Now, it says, which methods do you want to test? Really, I'm not going to use any of the gets. I don't care about testing the gets because we're going to do that when we test init. So we care about attack, care about status. We care about move, I guess. Move's not going to do a whole lot, but we could test it out. Get name, get type. Assess damage is important. We want to make sure that one works. And change alignment, we want to make sure that one works. So it just gives us a couple pre-done functions here is all that does for us here. And we have to say from ship, import, we want ship, we want cruiser, we want battleship, we want corvette. And we also want alignment. So I just want all of them so I don't have to say ship dot, ship dot, ship dot, ship dot, ship dot, ship dot, right? Over and over and over and over and over again. Okay, so for testing attack then, well, our base ships, I guess we could make one with an attack power and make sure it works, right? Sure, why not? So the 100% code coverage is if this line runs. We're technically not testing if it's not within range. Now we probably do want to do that though, right? So this is attack, we'll say within range. Again, this is not anything, I'm not going to mark you down if you didn't have these, but it might be useful to have a couple tests, right? For not within range, and another one for attack, same team, right? That we don't hit the same team, that sort of thing. So we're going to arrange, we're going to act, we're going to assert. Okay, so what do we need then to test an attack? Oh, we need, I'm sorry, we do need one test for init. Define tests init, or ship init. So I just want to make sure that we get out all of our values here. So this is a better one to start with here. All right, so what are we going to have? That should be tabbed in. There we go. So we're going to have, nope, not that far. There we go. So we'll have a expected name, I don't know, ship, an expected type. Ship, I think was capital there, right? We're going to have an expected X. We'll say 1 and an expected Y. Sure, how about a 2, an expected max health. 10, expected current health. Expected current health, 10. And what else do we need for ship here? Attack power and range, right? Expected attack power. Let's just do 10s everywhere. And expected attack range is 10. Okay, now we're going to act. We're going to make one of these. So we'll have a ship equals a ship. Given, right, the expected name, the expected X, the expected Y. We'll an alignment here, so an expected alignment, right? Hey, thanks so much for following along. Alignment. How about alignment dot us? You pass it the expected alignment. What else did ship want in it? So then a max health, an attack range, and attack power. So a max health, a range, and a power. This is getting kind of long. We'll bump it down a little bit here. Right? Attack powers. We didn't bother with X move and Y move, right? Because we're not doing anything with them yet. We can test those later if we want. Okay. And then we'll have a bunch of actuals. So we'll have an actual name is ship.getName, an actual x, ship.getX, an actual y, ship.getY, an actual alignment, ship.getAlignment, an actual alignment, there we go, max health, ship.getMax health, an actual current health. So these are a little boring to write, but it's good to make sure we're doing this right. Right, this is our way to verify an actual attack power, get attack. Oh, we don't have a get attack power. That's fine. Get attack power. We probably should have one of those. So I'll write one. Find get attack power. Turn self dot get attack power. Oh, attack power. There we go. So basically, if you have an attribute, you probably want a get method for it, because someone else is going to use it somewhere maybe. So that's up to us. Okay, and then we assert that they all match. So self.assert equal, and we just keep on matching all these here now. So we have our, oh, we need an actual type, shift.getType. Okay, we're just going to compare all these. So an expected name and the actual name. And we just go on down. So we have to type, we have X, we have Y, we have alignment, we have max health, we have current health, we have attack power. Actual X, actual Y, alignment, max health, current health, and attack power. Okay, and these should all be the expected. So expected type, expected X, expected Y, alignment, max health, current health, and attack power. Nope, attack power. There we go. Oh, is it not checking range? Did I not have a range? I gotta get range here. So actual attack range. Ship.get attack range. Range, okay, so we need another method for that. Get attack range. We'll probably just copy paste this one, right? Range and range. So again, if you didn't test all those because you didn't have the gets, that's okay. I mean, the code is definitely running. So you still technically have the 100% code coverage, but you're not really testing everything, so it's not ideal. Because just because the code runs, you probably want to make sure it does what it's supposed to do as well. And that's the funny thing with those code coverage metrics. It's like, are you actually testing all of the attributes that get changed, or is it just running? And sometimes it's hard to tell. Okay, so let's see. I just need to put in fail for a second. Put that fail back, and I just want to run this one, see if our init works. Our tests. And let's see if this one runs for us. Okay, and test ship init seems to pass. So all of our expecteds seem to work here. All right, do you want to do all of these? I don't want to take up too much time. Like, do you want to see anything particular? I'm happy to finish it if you folks want, or we can definitely move on to the new stuff. Whatever you think is going to work better for you. I'm open to anything. Were there particular ones you had questions about for the tests? I'm going to grab some more coffee. What do you think, chat? No errors? Yeah, we can finish it, sure. No problem. All right, so then attacking if it's within range. So we need 2 ships. Now, we don't necessarily need all of these expected values, right? Because that's going to be really big and ugly here. But what we're doing then, so we're going to, in our assert, or our range here, we're going to have the, I don't know, we'll have a ship equals a ship, and we can give it things. We don't really care what the name is. What do we want, an X and a Y? Give it 0 and 0. Probably doesn't matter for X and Y. Give it an alignment. So now we need 2 different alignments. So I have alignment .us, and then we need the max health. Sure, how about 10, and a range of 10, and a attack power of 10. Sure. Let's then, and then we'll make a target ship, or other ship, I don't know. I'll call it a target, why not? Here's a ship. Now, these can be all the same things except for the other team. I'm going to make sure that this is in alignment with them. Right? So that's, we're arranging, we're setting up the variables we're going to need here. And then what I want to test is that attack changes their health. So I'm going to have an expected current health. We should be down to 0, right? If your attack power is 10, oh, let's say 5. We'll change our attack. We'll go 0. Why not? So your attack power is 10 and you hit the ship, it should do 10 damage. Okay? So then in our act here, we're going to say ship.attack. That's the target. And then we'll have an actual current health is the target.get current health. And then we're going to assert equal self.assert equals, there we go, that the expected current health matches the actual current health. So can we attack if we're within range? Let's run that one. This is our assert section. Yeah, that worked. So now we're going to just basically take the same pass here. No, that one. Nope. All just for space. Now, if we are not range, so if we are at 0, 0, and they're at 10, 10, and our range is 10, they should not get hit. So your health should stay the same here. Right? And attacking someone on the same team, your health should stay the same, even if they are within range. Okay, so we're going to check those ones. And then for status, right, we'll make a ship, and then we'll get the status back out. So our act then is going to be status is ship.status. Right, this should return the string, and then we'll assert self.assert equal the expected status and the actual status. Oops, sorry, that should be actual status, right? And then so our expected status should equal. Now I think we can get away with this triple quoted string here because I think we can do it this way. So we should give it a name then. So I don't know, test should be test, and the tabbing on this might be a little bit funny. I think no, we want it shifted in, right? So test is ship, and current health was going to be, let's see, oh no, just regular health. Health would be 10, and location should be 0, 0, I think. Does that work? Does a triple string need to start there? I think it starts there. So the triple string is like a raw string, so all those new lines are going to stay in here. So let's try that one. I want to see if that one passes now. I'm curious. I don't need a breakpoint. Just run it. Just run. Oh, it failed. Okay, so let's see. So it says we expected test ship health 10 location 0, and we actually got test type of ship health 10 location 0 comma space 0. So our spacing is off here. So let's go. I think we should have a space here then. Oh, am I backwards? Oh, okay, so it showed this was the expected and this was the, I think that's what it was. All right, so we'll fix that. Let's run it again. Let's see. Okay, test ship 0, 0. Oh, I think I think test has to be on that line. I think it's what it is. I think I'm getting one extra new line. These triple quote strings always mess me up. I just gotta go play with them a little bit. All right, we're close. We're close. Okay, what are we not getting here? Test, type, the health, location. Those ones look pretty good. Right? Health is 10, location. What are we missing? Oh, the triple string maybe ends the quote there. Is that what it is? I think maybe I got an extra new line. There it goes. Now it passes. Okay, so yeah, if we went down a line, we'd have one extra new line, and then it's not actually the same. Okay, so for move, now we're calling assess damage inside of move, and we're changing the x and y. Now I haven't given it x and y's yet, so we should do that, or we can test this with like a cruiser or a battleship or some class that actually does something, right, with a regular ship, or we can just pass it a move here. Why not? We'll pass it a move. So then move, we're going to arrange, and then we should give it, I don't know, how about -1 and -1 for the moves. Oh, let's give it 1 and 1. Okay, and then how about we do some damage too? We can assess some damage. We'll assess 1 damage here. Let's do 2. And then we're going to act. We're going to call ship.move. So then what I'm going to have here is an expected current health. Should be 9, right? Because if we take away 2 and then we add 1, we should go up to 9. And then an expected x should be 1, and an expected y should be 1. Right? So we'll have an actual current health, ship.get current health, and actual x, ship.get x, and an actual y, ship.get y. Okay, and then we're going to assert, self.assert equal. We want the expected current health and the actual, sure, we'll do the y's first, why not? Assert expected x, oops, I had x right there, and an actual x, and assert expected current health and the actual current health. Look at that, those like type ahead suggestions were awesome. Let's try that one. Okay, test move passes. So we move, we got our health back. Assess damage then, right? Well, we've actually already done it here, basically. Now this one here is, we need a couple cases, right? Does not go below 0. Right, so if I try and assess 20 points of damage, I should stop at 0, right? We don't care about the x and y, so we'll get rid of the x and y. We don't need move, but then assess damage is what we're acting on here. So if we do 20 damage, it should stop at 0. Right? And then assess damage does not go above max. Right? It should stay at 10 if I assess negative damage. So now I'm getting in my assess damage function here, I'm getting into each of these, trying to go over the current health and trying to get under 0. Now I don't have one for regular, but I mean that line of code just runs, right? We're automatically doing that damage. So with the like above or below 0, we're testing it already. Okay, and then change alignment here. We got a ship. And we'll have an expected alignment equals alignment dot them once we change it. Oops, them. And then we'll act, and then we'll assert. So ship.change alignment changes us to them. We can assert equal. Oh, we want an actual alignment, then actual alignment. Ship.get alignment The expected is the actual. Okay, and we want to repeat that. So this is us to them, and we want to do a them to us, right? Them to us. So if we start at them, we should change it to us. Oops, them. Okay. So now we've got all of our tests filled out. Let's run them all. We can run all of them at once. Run our tests. All right, and they all seem to pass here. So we're feeling pretty good about chip. Okay? Feeling pretty good. So these, maybe I should have named all those tests ship. Now I feel a little bad here. Let's do that. Let's do a find and replace. Nope, that wasn't it. That was not the thing I wanted. Let's go to view. I don't know. Is it code? Is it find and where's the find and replace? Edit, find, and replace. Okay, Control R for find and replace. So we replaced test with test ship. So not this first one, but I want to go to the next one. Replace ship attack, ship attack, ship attack, ship status, ship move, ship assess, ship. Because I'm going to cheat here and put them all. Oh man, I want test ship with test ship underscore because I spelled it wrong. So not that one. I want underscores here. There we go. Okay, right, use the tool. Now we got better methods here. Better function names. Okay, what does it not like about that one? Too many blank lines, sure. Make sure it's nice and happy with us. We can run all the tests again. Okay, so now we're going to define some more tests here then for Battleship. Define test Battleship. What is special about Battleship, right? What do we know about Battleship? Well, the only thing special that it does is the attack and the status. So we want one for attack, and we want one for status. That's Battleship status. Okay, so I'm just going to go copy some of these ones here. Where's some of these ones here? Did we do an attack? I feel like we did an attack. I don't remember. Where's my status? Here's the status one. So let's do status first. So this is going to be test, but then the type will be Battleship. Oops, so we didn't do that one. So that's right. So Battleship needs to override get type. Find get type. Turn Battleship. So if we don't do this, right, the get type is going to always return ship. A little bit funky here. And then the health should be, what, 100 or so? Right? And the location, sure. And we should also have then torpedoes. Torpedoes. We should have 10. I think we need to tab that one back in a little bit here. So this will be a Battleship. Here. Let's give that one a try. Oh, we're running short on time. I'm sorry. We're getting close. Okay. Uh-oh, what happened here? Oh, goodness. Define test Battleship status. Unexpected indented block. Oh, because this one here was missing here, so we just need a self-fail for a second. Okay, now it should run. So it wasn't able to finish that because this thought this method wasn't complete. All right, so Battleship status passes. Fantastic. So we're feeling good about Battleship. Now for attack then, we're going to, let's do where I think we attack one of these ones here. Oh, we were doing that with assess damage, weren't we? When we, oh, that was, I thought we had an attack. We did attack within range, right? Attack within range. Okay, here we go. So for attack then, we're going to make a Battleship. Battleship, and it can just attack a regular ship. Why not? So it doesn't need to know the rest of that for Battleship. And we want to make sure it can do the right amount of damage, right? So where's ship? Let's give it like 50 health, right? So then the current health should be down to 30 once we attack it here, right? Because it uses a torpedo. And then I guess we also want to check the expected torpedoes. Expected torpedoes. right, should be 9 after we use a torpedo. So then we'll have an actual torpedoes, ship dot. We don't have a get number of torpedoes, do we? Torpedoes. So we'll have to write a function for that. We'll add that to battleship. Define get torpedoes. Return dot torpedoes. Return. There we go. So that way I can get that value back out here for getting my torpedoes. And then we can assert those match. So assert equal my expected torpedoes and the actual torpedoes. Torpedoes. Okay. Let's give that one a try. So we should be able to hit somebody for 20 damage instead of just 10. All right, so battleship attack seems to be working. So in terms of code coverage, it's going. If we wanted to make sure we do less damage after we've used up all of our torpedoes, we can do that too. So let's do one more. So we'll do attack out of torpedoes. Right? So let's give them 300 health, right, per ship. So after we hit with 10 torpedoes, they should be down to 100. One more hit, they should be down to 90. And we should have no torpedoes left, right? So what we want to do is we want to say for attack in range 10, no, 11. Let's call ship attack target. Oops. Oh my goodness, the tabbing here is terrible. So we'll attack them 11 times, right? On the 11th hit, there should be no more torpedoes, and their current health should be at 90, right? So 20 for each of the 10 hits, and then 10 for the next hit. Okay, so once we run out of torpedoes, we're doing the normal amount of damage. Looking good so far. Okay, how about cruiser? There was really nothing to test in cruiser other than the XY move. But we know move works. So really, there's nothing to test in cruiser. Which is, because it has no functions. All there is an init, and we know our init works in ship because we've already tested that code. Corvette, then, we can test the attack. So let's do a test Corvette attack. Oops, these should be battleship status, battleship. Okay, good. So we'll do these attacks here. For Corvette. So Corvette, an us and a them. Now we just need an expected alignment. Alignment equals alignment.us. After we convert them, we'll have an actual alignment. Target.getAlignment. Then we can assert that the expected and the actual match. Right? So if we take a Corvette and we attack a them, it converts. Cool, that one's working. So we feel like attack works here. And then repair ship, we want to test repair here. So we'll do a find test repair. So we need a repair ship, we need a ship that gets damaged, and then the health, right? So both the same team, right? Team us. This is a repair ship. Repair, isn't it repair? Repair. Did I not import repair? I didn't import repair, did I? Repair. There we go. Import the repair ship. We didn't really do anything with cruiser because that was kind of boring. So testing repair here, we'll make a repair ship. We want an expected current health is 50. And then we're going to take the target and we're going to assess some damage first. Let's assess 10 damage and then we'll attack the target. And then we'll get their current health. We'll have an actual current health. And we can compare the two. Okay, let's give that one a try. All right, folks, an hour and 10 minutes or so, and we're in. I think we're done. 100% code coverage. I didn't do the UML diagrams. We've talked about those. I don't think there's a whole lot of interesting stuff there, if that's okay. Happy to show them to you if you want later. But we got to talk about the next project already. My goodness. Next project. That's not okay? So let's talk about project 1. No. Yeah, plus, add an assignment. Project 1. So this is due in 2 weeks. So that's the 17th, 3:30 p.m. This one I think is another 10 points or so. I'll double check here in a second. And this one, I'm trying to see if I've got that in a folder here, or I've got to do some quick copy paste. So we're going to do a checkers solver here. So we're going to build the game calculator here, not the full game or anything, don't worry, but for a given checkers position, what we want to do is we want to calculate the move that will capture the most number of pieces. Okay, that's what we want to do here. So that's the goal for this one. So let me go, I think I've got it in my folder. Let me look and see. I'm going to put this on my other screen real fast while I poke around my files. Sorry, I'll be boring for a second here. Oh, I need the classroom link too. The File Explorer in Windows 11 is like horribly slow, and it makes me super sad because that was always like a pretty quick tool, which was a bummer. All right, so let's do a new assignment. CIS Winter 2022, Project 1. Oh my goodness, like my File Explorer is just locked. All it does is look at files. Okay, we'll do our Python template. It's not in the list. Hang on, so it's Charneski. Help if I can spell my own name right. Python template. There we go. Feedback pull requests. All right, cool. We got the link. Please submit the feedback pull request URL for your project. So I'm almost there with this. Almost there. So this is a recursion project here. Recursion. My goodness, File Explorer makes me want to cry. I don't. Okay, so give me a second. I gotta go grab it off of here then real quick. All right. I'll get in just a second. Sorry. That's the wrong one. So it's got a very particular input for this, is the idea with this one. So you're going to read in a bunch of input that's going to tell you where all these checker pieces are. There we go. Excuse me. Grab this. Sorry, almost there. Nope. Okay. Hang on. I was in the wrong one. Do you want to do checkers or you want to do... Let's do the maze solver. I think this might be more fun. Anyway, we'll do the maze solver. So what we want to do is calculate the shortest possible path for a maze. We talked about this a little bit, but we did the basic maze solver algorithm. We never went and implemented it. So what you want to do is have a 2D list of the maze to solve. We're going to use this backtracking recursion to find the shortest solution. So the idea here is that we need to find every possible solution and then find the one that is the shortest of those. So we can't just stop as soon as we find a solution. We need to let it do the unwinding and be tracking those number of steps as we go. I know there are solutions online, and a lot of them don't use backtracking recursion. Right? The goal here is to apply our backtracking recursion algorithm to this, not something you found online. So if you turn in something that looks very suspicious, I'm going to ask you how it works, and if you can't explain it, you're not going to get the point, that it will not go well. So solve should set some value like the shortest path steps to the shortest path step count. And then we're also going to unit test it for this one as well. So we're going to write some unit tests where we know mazes have different number of paths, and we'll go from there. It'll be more fun than the checkers one anyway. And I found this one first, and we're out of time. That sound okay? Let me publish that one. So like with your maze, you want like, you can have something like an X marks a wall like we looked at, and you can leave breadcrumbs around. So you need to do the breadcrumbs so you don't step on, like get in an infinite loop here, but we need to be taking those breadcrumbs off as we come back, not marking them as dead ends, right, if it's not a dead end. So got some interesting pieces to this, not just implementing that maze solver, but doing the shortest possible solution. It should be fun. Okay? All right, sorry to run over here. Hopefully it went well with the first project. We got the second one coming up, and then we've got 2 weeks, so we're coming up to the midterm. We'll take a week off for a break, and then we'll come on back. Two more projects and a final project. So if you got any questions, let me know. If not, I'll see you on Tuesday, folks. Thanks.